my name is Aaron Summerall, and this is Lab 2, Lines of Charge. Introductory information about this lab. This lab focuses on electric charges and the interaction between two charged objects. The purpose of this lab was to determine the amount of excess charge on one piece of tape and to simulate the interactions between two charged tapes using GlowScript. Principles: Coulomb's law of force and Newton's third law. The results: the tape was positively charged and repelled the U-tape that attracted to neutral objects. The tape had a charge of 6.07 times 10 to the negative ninth, and the tape had 3.79 times 10 to the 10th excess electrons. Notes and assumptions. Throughout Lab 2, the system involved was the charged U-tape and whatever objects were interacting with them. Assume that the charges were evenly distributed throughout the entire surface of the tape. Air resistance and other outside charges should be ignored because they were too small to impact the experiment, and assume each U-tape was charged the same. Our data and measurements for this Lab 2. The length of the tape was 0.2 meters. The mass of the tape was 0.0002 kilograms, or 0.2 kilograms. The distance between the two tapes that was measured was 0.013 meters. The gravitational force is 0.002 newtons. The electric force was 6.07 times 10 to the negative ninth coulombs. The measured electric charge on the tape was 6.07 times 10 to the negative ninth. The excess electrons were 3.79 times 10 to the 10th, and the excess electron ratio was 9.97 times 10 to the negative ninth electrons to atoms. So the calculations of this is the Lab 1 calculations, since these labs are so similar. The force of gravity, mg, is 9.81, and then we calculated for the electric force, which is equal to the force of gravity due to Newton's third law. And then going down to the number of excess electrons was Q over E, and that's 6.07 times 10 to the ninth over 1.6 times 10 to the negative 19th, and that gave us 3.79 times 10 to the 10th electrons. And to calculate the area of the tape, we used length times width of the tape and got 0.0038 meters squared. The number of atoms on tape, we just took the number of atoms times the area and got 3.8 times 10 to the 17th. And then for the ratio of excess electrons to one atom calculation, it was 3.79 times 10 to the 10th over 3.8 times 10 to the 17th. And that gave us 9.97 times 10 to the negative 8 electrons per atom. So the estimations of the uniformly charged or distributed charge, we can use the equation for the electric field of a uniformly charged rod to estimate the charge of the tapes. We can set the magnitude of the electric force equal to the magnitude of the gravitational force. And shown below is the equation where you're setting these equal to each other and solving for Q, and the bottom is going to be solving for Q. So in the second lab, we had to go into GlowScript and create two line charges instead of actually using point charges for Lab 1. We created two line charges and showed the magnitude of the electric force acting on each tape. So that's what's displayed on the screen right here. Potential sources of air in this lab. All external factors such as air resistance and outside charged objects should be ignored. Assume that the charge is evenly distributed throughout the surface of the tape. There could have been human error in measurements as well. And additional questions. What if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to get the value that you got with your line charge model. So I'm comparing the value of the point charge model at 6.07 times times 10 to the negative ninth, and then the line charge model with 2.51438 E at negative 8. So these values, or I guess that's going to be in the second part. Why do these values and estimations differ? Which one's more likely to be real? So these differ because you use different calculations to get to each of these answers. So the line charge model, where you solved as a uniformly charged rod, is going to be more, it's going to be a closer value to the true estimation, and this is because the charge is spread out evenly over the entirety of the rod.